Modern high-speed computing relies on a steady flow of helium to manufacture the microchips found inside every consumer device. In the aerospace sector, it is the only gas capable of keeping rocket propulsion systems pressurized and stable during launch. Within the healthcare industry, helium provides the extreme cooling required for MRI machines to produce clear diagnostic images. This gas is also an essential component in the production of advanced electronics and the operation of large-scale scientific research facilities. Because there is no synthetic substitute, a disruption in the helium supply chain would effectively stall production across the medical and technology sectors. Despite its critical role, the way we source helium is surprisingly indirect. The world does not generally mine for it as a primary target. Almost all current helium is byproduct, captured as a minor secondary element during natural gas processing. This creates a bottleneck. Because availability is tied to methane, the helium supply dries up whenever fossil fuel markets fluctuate, regardless of tech industry needs. The global market is currently managed by massive processing facilities like this, which are designed first for energy production and only secondarily for helium recovery. To ensure the stability of advanced manufacturing, the industry is moving to decouple from the natural gas sector by hunting for dedicated independent helium reserves. This shift is centering on East Africa, specifically the Rukwa Basin in southwest Tanzania, which is emerging as a significant industrial gas province. Rift Helium is advancing the Upepo Project here as a test case. Their strategy focuses on primary helium. Instead of waiting for pipeline byproducts, they target helium pockets directly where they occur naturally, completely independent of fossil fuel deposits. The project is in its final regulatory phase, completing the environmental impact assessment required to begin fieldwork. Finalizing this assessment is the milestone that transitions Upepo from a geological model into an active physical exploration program. The project's timeline is defined and resilient. Because the upcoming phases are fully funded, operations are not subject to the delays of a typical capital raise. A 3D seismic program is scheduled for the third quarter of 2026, using sound waves to create a high-resolution map of underground rock layers. This data will be interpreted and processed through the end of the year, culminating in an updated resource assessment in early 2027. The final phase moves to physical recovery. By the first half of 2027, the company will launch a two-well exploration drilling campaign to confirm reserves. This transparent, funded schedule provides the global market with a clear countdown toward a new, dedicated source of helium. For Tanzania, this project represents an evolution of its resource sector, moving beyond the traditional bulk mining of ore and minerals. Developing the Upepo project allows Tanzania to enter the specialized industrial gases market, providing a path towards significant economic diversification. Globally, exports from East Africa would provide technology manufacturers with a much-needed alternative to the current byproduct-dependent supply chain. This marks a change in how we view exploration. We are looking for the foundational gases required for high-tech life, not just energy. By backing primary helium projects, capital is being deployed to secure the raw materials necessary for the next generation of global manufacturing.